Hey guys, welcome back. So today we are going to continue with Unit 4. So what we're going to be going over is moles, atoms, molecules, and the empirical formula. So what you need for this is a handy dandy calculator. You need this in order to solve for for basically most of the questions in this unit or any unit that involves moles, atoms, and molecules in the empirical formula, because this is a very math heavy section in this unit. So you're going to need a calculator, you're going to need a pencil if you want to write down any of my examples, or just in general write down any chemical equations in general, just so that way you have extras and you know what to look over to reference, and just a good study guide, an extra eraser, and of course your periodic table, because you are going to be needing this very often during this part of this unit or with any chemical equations. So without further ado, let's get started. So let's talk about moles, molecules, and atoms. So moles, molecules, and atoms are basically conversion units of an element. So if we look at the periodic table, all of the elements' atomic weight is a conversion factor for 1 mole, because each element, each atomic weight is equal to 1 mole. So automatically, let's just look at oxygen. 16.00 grams of oxygen is equal to 1 mole. 19.00 grams of fluorine is equal to 1 mole. And 35.45 grams of chlorine is equal to 1 mole. All of these atomic weight are all equal to 1 mole. So it is a conversion factor. And molecules is a conversion factor of moles, which makes it a conversion factor of the elements. And the same thing with atoms, 2 molecules to moles to the element. So they're all conversion factors. It's just that you're going from grams to the smallest subatomic particle of the element. So you're going from grams, what you have, to something smaller, smaller, and smaller, and so forth, until there's nothing left you can do. So there it is. That is moles, molecules, and atoms explained with a definition of sorts. Now let's go into this. So Avogadro's number, you're going to need this in order to solve for molecules and atoms, because this number is going to help you get to these. Without this, you won't be able to get to either one of them. So let's look at this problem. Let's look at moles. How many moles of copper are in 25 grams of copper? So as you can see, I write down the atomic weight of each of my elements, so that way I don't have to keep going back to the periodic table. That way I just have it right here with me, so that way I can just look at it and get it and just use it when I need it. So in order to get from moles, so let's just pretend that this is not there and that answer at the bottom is not there. So in order to set up for moles, you do it like this. You start with what you're given, so it's 25 grams of copper times 1 mole of copper over the atomic weight of copper, because as we've said, the atomic weight of any element is also a conversion factor for mole. So this molar mass is also equal to 1 mole. So in order for us to get to moles, what we would do is we would cancel the grams, and now we're left with moles. So there you go. That's how you go from grams to moles. And if you remember dimensional analysis, this is that's going to help you very much with this. So how about, since we've done moles, what about molecules? Let's go to molecules. So this is where Avogadro's number will come in. So if you want to get to molecules, you multiply this times 6.022 times 10 to the 23rd molecules divided by 1 mole, because Avogadro's number is also equal to 1 mole. It's also another conversion factor. So to get the molecules, you multiply across by this, you multiply this, divide by this, and then you get molecules. So, and with dimensional analysis, cross out the moles, and then you're left with molecules. Simple, right? Now let's go to atoms. since we've done molecules, let's go to atoms. So, how did I get one atom? Well, it's kind of simple once you think about it, because there's only one copper. If you're trying to solve for atoms, look at how many of the elements you have and just add them up. That's how you can figure out atoms. So we have one copper here, so I'm going to put one atom copper here, and then of course one atom is also equal to one molecule, because like I said, it is a conversion factor of each other, so molecules cancel, and then we're left with atoms. Solve, multiply it out, divide it. This will be our answer, and if you remember significant figures, this is the lowest sig fig of this whole thing, so we are going to make it the same amount of numbers. Now, for atoms, here's another example. So, as you can see, there's one copper and two oxygens. My atoms will be 3 because 1 plus 2 is 3. That's how you can do, atoms. So, there it is. That's moles, molecules, and atoms. So now, let's go to the empirical formula. So the empirical formula is basically the lowest whole number ratio of a compound. So to solve for it, we have to get the number to moles. So if we remember from going from moles, molecules, and atoms, the first part, just moles. You're just going straight to moles. Then once you've gone straight to moles, whatever number of that element, whatever element has the lowest mole, you're going to divide that. You're going to divide all the other numbers by that lowest number, which is where step 2 is. And then 3. 3 is only if when you divide all of the numbers, all of the moles, by that lowest element, that lowest mole ratio, will it equal to something that is not a whole number. That's when you have to multiply that, like 1.5. It's not a whole number, so you have to multiply it by some number to get it to a whole number ratio. So let's look at this problem. An oxide of chromium is formed to have the following percent composition: 68.4% chromium and 31.6% oxygen. Determine the empirical formula of the compound. So like I did, I wrote down the atomic weight of each of the elements that are going to be used, and now I can somewhat begin. So if we do percent compositions of this, don't worry, it's not that bad. So if we're given like percentage of a chromium, because we don't know exactly how much we have, this percentage is what we're going to use for grams. So as you can see, 68.4% became 68.4 grams of chromium. And then of course I did like I did with moles. I crossed out the grams and I'm left with moles, and I get 1.315 moles chromium. And then I do the same thing with oxygen. 31.6% of oxygen becomes 31.6 grams of oxygen. Cross out the grams, because 16.00 grams is also equal to 1 mole. Cross them out, and then we get 1.975 moles of oxygen. Divide both of these by 1.315 because this number is the lowest of the two, and we get 1 for chromium and 1.5 for oxygen. So 1.5 is not a whole number, so we have to multiply it by 2 to get it to a whole number, which becomes 3. And we multiply this by 2, it becomes 2. And then this is our empirical formula. This is what we are trying to solve for to get. So Cr2O3. This is the answer, and that is how you do empirical formula. So I hope that this helps. Have a nice day.